In exercise 2, consider two urns, A and B. In urn A, we have 2 red balls and the 3 white balls. In urn B, we have 3 red balls and 5 white balls. In the first experiment, experiment 1, 2 balls are drawn simultaneously from A. Find the probability that both are white. This question is direct. It's the number of accepted cases, which is choosing 2 out of 3, since we have only 3 white balls in urn A, over choosing 2 out of 5. So 2 out of 3 using calculator or whatever, this is 3, whereas this is 10. So the selection here is a pair of balls. So we have this number of ways where we can choose 2 white balls out of 3 possible or 3 available white balls. Let us move to experiment 2. A player rolls a fair die, 6-sided die. If the die shows a 6, then 2 balls are drawn at random from A. When I say at random, this means simultaneously. Otherwise, 2 balls are drawn simultaneously but from urn B. Consider the following events. W, both balls are white. A, the balls are selected from A. So the first question is calculate probability of A slash or probability of actually B. B, we don't need to mention the event B here, it's A bar. Calculate the probability of W slash A. Actually, W slash A means the probability that the 2 balls are both white, knowing that they are selected from urn A. If we are choosing from urn A, then the probability to get 2 white balls is already calculated here. So consequently, I have this number actually. This is directly 3 over 10. Had I calculated in experiment 1. Actually here, before I start my questions, you could have drawn a tree. If you throw or if you roll a fair die, you will either go to urn A, and this is in the case where the die shows up a 6, and the probability of that is 1 over 6. Or you can go to urn B, and that's 5 over 6. If you go to urn A, you are going to select 2 balls simultaneously. So either both are white, and this event is denoted by capital W, or not that. Not that means W bar, which means the 2 balls could be both red or 1 white, 1 red. I don't care about details here. We are only here concerned about the white balls, if both are white or not that. So both white, and that's W, or not that. Do we have these numbers? This number, we have it here. This number is nothing but 3 over 10. So that number is 7 over 10. I don't have these numbers yet. But what about the questions? The other questions are, so first of all, I asked you about W slash A, and we said that this is 3 over 10. Let me ask you to find the probability of W. So if a player plays this game by throwing a fair die, then going to a certain urn, one of these 2 urns, and selecting 2 balls simultaneously, What's the probability that the two balls selected are both white? If you look at the tree, you have to use law of total probability. The probability of W is probability of W intersection A plus W intersection A bar, which is B. And that's probability of W slash A times A plus probability of W slash B times B. Do we have these probabilities? W slash A we have just calculated in experiment 1. A is to get a 6, and that's 1 over 6. What about W slash B? Choosing B is clearly 5 over 6. W slash B means getting two white balls, knowing that the selection is done from urn B. If you look at urn B, you have 5 white balls out of total, which is 8. So choose 2 of 5 over choosing 2 out of 8. You can use calculator to find this number. I think it's 73 over 210, but I'm not sure about the numerical calculation. You can use your calculator just to get the numbers. A final part here, I may ask you about the final part. Knowing that the two balls selected are both white, find the probability that they are selected from urn B. Although this problem is also a slash, but W slash B can be interpreted and answered, and here it is. Whereas B slash W in this part is not that easy, so I prefer to move to a formula, which is B intersection W over probability of W. What about B intersection W? You can use the tree. It's this number times this number, which is already calculated here. So this will be choose 2 5 out of 8 times 5 over 6 over W, which I claimed it's 73 over 210, but which I'm asking you just to check about the numerical value by using calculator.